join me in welcoming Chris and Johnny.
So you all realize that you're in a deep learning talk today. The title was a little vague, so I hope everybody's ready for that. So today we're going to talk about a model that we built. CoStrategix is a consulting company that we do a lot of different types of work. We do digital work, we do data and analytics work. Johnny and I are probably 2/3, I guess, of the data analytics practice. So that's kind of who we are. We're up in Blue Ash. If you're up there at Summit Park getting something to eat, stop by. We'll show you around the office, no problem. It's right there in our backyard. So back to the model. What we're going to talk about today is trying to find things in text. What do you think I might be looking for in text in a business context?
Issue.
Complaint.
Complaint. So that could be related to sentiment, right? How people are feeling about that support experience. What's another really common application of what they call named entity recognition, right? Looking for things in text. What would be interesting to me for my bit, like if I went to a big retailer here in town, or some of the political things that are going on right now, right? Today's election day. What might you be looking for in your text?
Organizations.
Organizations. And especially on that retail side, what else might you be looking for? Come on, Johnny can't answer all the questions, guys.
Trends.
Trends would be one.
Brands.
Brand. There's the guy right there. You got it. Back there in the back. There is audience participation, as you can see in this talk. I will be giving away the next audience participation. We'll have a prize. So stay with me. You got to pay attention, though. I move kind of fast. Here's a quick outline. We did the introductions. I gave you a little bit of a fun intro there. We're talking about the background of what the problem space that we used for this particular client. This is actually based on a live client. We're not going to be using any of their data or names or anything today, but we've kind of obstructed it using some public available data. Methodology, Johnny's going to do a demo of the model and the outputs, and we'll have some discussion afterwards. Sound good, everybody? We're still into it? I'll let you leave now if you want to. Okay. So there, get that. We'll come back to these slides. So, it's really hard to teach computers to read, isn't it? So, have any of you guys played around with DALL-E 2 since it came out in the last couple of months? Yeah? So, I actually gave it the prompt, a machine learning algorithm learning to read, and I wanted to draw me a picture. That's what I got. So, as you can see, those guys obviously have a lot more data and probably are a lot smarter than me. It's not an easy problem, is it? So here's a scenario. I'll give you a minute to take a look at that and I'll continue. So, it's really expensive, right, to get your people to give you human in the loop labeling of what a brand is in a random product stream of text. It's expensive, it's difficult. If you use algorithmic methods, you got to maintain those algorithms. And I'm not talking about data science there, I'm talking about literally software developers, Levenstein distance and TF-IDF and all those text-based manipulations of data, like those can get wildly out of control. The reason we knew this is we did this for the same customer a couple years ago. And it did get, there was one guy that understood how it worked. Whereas where you can put it in a model, and the model will refresh, it'll handle drift. So that's why we kind of shifted more to a machine learning approach with this. All right, here's this, the next audience participation. I need 3 volunteers. There's 1, 2. We can go with 2. Stand up. I'm not going to do anything weird, I promise. It's not anything weird. Just hop up. Your best guess at how many millions of products are in the Amazon marketplace today? By the last estimate.
How many millions?
Yeah, we're prices rights rules. Closest without going over. There we go. 100 million? What's your guess?
In terms of like different SKUs?
Different individual items, yes. Different individual items.
Tens of millions?
Tens of millions? And we'll see the answer to this question. Let's see who was right. Okay, I know who's right, but we'll see. All right. You're gonna need a lot of training data. Do we think it's 100 million? Or who thinks it's higher than 100 million? That's our biggest answer right now. Oh, Higher than 200 million. All right, higher than 800 million. Okay, you in the back? Well, survey says, well, it's the next slide after this, sorry. So we're gonna talk, that's the second challenge. I got you excited, see how excited you got? So the data's really noisy, right? Has anybody looked like when they've been shopping on Amazon or shopping on Walmart.com or BestBuy.com? Have you been looking at like those strings of text that have abbreviations and the brand names are cut off and all these things? And these are some examples from the training data set that we used for this this talk. Call out some of the things that you see going on over here that would make it especially difficult for a non-human to read this. Anybody see anything? Like, we're humans, right? So we have this bias of like, that's easy. That's so easy. But what's going to trip it up? What's going to trip the algorithm up?
All the sizes are listed differently.
Sizes are different listed. There's abbreviations in the sizes. What else? There's a hint right over here, by the way. It's kind of small though. Yeah, there's punctuation in there, non-text, mo hata, mo beta. That's not most corpuses when you're training an algorithm, right? But the other thing is that you need a ton of data, right? There's our answer. 353, I think it's maybe a year old, that estimate. Again, it's an estimate. The only one that really knows is Amazon. But 2 million brands. Can you imagine how many instances of products you're going to have with that to have that brand name in it or that product name in it? It's not a small number. I heard somebody want to do something in 64 back there.
You gotta use the integer 64-bit
Yeah.
integers in that.
Yeah, it's huge. So what are we going to do? Well, we're going to make it up. Synthetic data is a fancy way for saying make it up. Or educated way of making it up, I guess. Or really all we're going to do is we're going to create 3 extra data and boost it. In the case of our example that we're basing this on, there's a paper that was published by Home Depot, and they actually create one golden record data set where they have their people label the instances, and so you have a human error. There's even error in humans, right? We know that. And then you take a synthetic data set and then the product catalog data, which unfortunately we don't have a product catalog for Amazon for this example, but with the client that we worked with, we did. And so you make those 3 data sets, send them through iteratively through the model architecture, and it updates, like in the paper example for Home Depot, they had their algorithmic method was at about a 0.69 or so F1 score, and it was a 0.93 by the time they did the iterative training and added the synthetic data. There's a reference on one of the slides to the article as well, so you'll see that if you want to go look yourself. And we also, it sustains that performance because you can just put new synthetic data in and refit the algorithm again. So it responds really well. So our data set has about 9.4 million products across multiple categories. We focused in on grocery and gourmet food for this exercise and for this conversation because that was pretty similar. Grocery was kind of similar to the client that we were doing the original project for. And this is the link to the data if you want to go play with this yourselves. So this is actually hosted at California Davis, and there's some articles related to that as well on that landing page right there. So you can come see me after the talk, or we can work with Larry to get that distributed out. This is all publicly available data that anybody can use. Now I'm going to hand over to Johnny to talk about the model and the demo.
Perfect. All right, so keeping in mind the overview we gave before, you're an e-commerce platform and you want to roll out some new initiatives, but you're struggling with your data problem. You don't have a lot of data to really train and activate models like you want to. So we're going to talk about this particular solution architecture, which allows you to get better performance out of models that you train using the same size of data that you originally had. So if we start just kind of looking at the overview of the model, you start off with your catalog data. Catalog data is just a list of your products and services that you offer as a part of your business. And you create this golden set of records going from the catalog up to create these human annotated numbers. And so creating human annotated records can get expensive. It can become a long, taxing project, so you have to limit yourself to how much you can actually label data. because for a lot of deep learning methods, you need a lot of labeled training data. So in order to create your synthetic data, what we did is we actually, we're going to show you the model that we're going to use next, but we created synthetic data based off of our catalog data. And this is just trying to simulate combinations of brands and products that exist in your catalog that aren't completely labeled. And you're allowing your model to iteratively train on your golden records. You test it on your synthetic data to test performance, and you're looping back some of those synthetic data pieces into your model to, one, reduce bias, increase your training data, and ultimately to increase your training performance. So this is our model architecture that we decided to go with. We are using a BiLSTM, which is a bidirectional long short-term memory model. It's a next generation of a recurrent neural network. And a recurrent neural network is a deep learning architecture that allows you to maintain relationships between long sequences of information. So it's a way that data scientists develop this algorithm. It's a way for us to be able to say, how can we predict and how can we do inference on information that is time dependent? And then when we're talking about text, there's a lot of dependencies with time and position. So you can run the demo for me, yep. So we're gonna launch over to our demo to kind of walk you through our workflow, talk about some of the steps we took, and then we'll talk about some results when we get there. So one thing to keep in mind for our demo is that although we had 9.4 million products that we trained it, I will show you the results from those in the slides. But for the demo, we're using a smaller sample set for training time and so we can keep this demo going. So the results that you'll see printed out on the console, they're going to be overfit, they're going to be skewed because it kind of returns to our original problem. Without a lot of training data, you're going to have misinformation. Well, while Chris is working to zoom in on the screen, starting from the top, we're using a lot of standard Python libraries. We're using Pandas, NumPy, and we're using TensorFlow as our deep learning framework. We start our process by, like every other process, we're reading in our data. We currently store our data locally, but there's a lot of other ways that you can read in data, whether that's streaming from a cloud service, you're kind of pulling it in from different disparate data sources, but we're using our local training set. And then we go through a process of actually doing our data prep. And what our data prep looks like is, our data set looks like it has 4 columns. One column is a product and brand description that has brands and products hidden within the text. And then we have a label column that tells you what particular word in that description is the brand. And so we utilize a method of, we tokenize our strings to isolate the words in our text. And we use a couple different methods so that we can then identify what's the brand that exists in that token so that we can have that training and description mapping. And that's actually what we use to input into our model. Has anyone used deep learning applications either in class, at work? How did you, so deep learning is difficult, first of all. What are some applications that you use it for?
At one point, so they're releasing Nationwide Mutual Insurance Company in Columbus. We were working on, or I was working on developing essentially a recommender system.
Okay.
So attempting to essentially learn sequences of behavior and pattern behavior in some of the financial advisors with which we interact. And so, you know, we send them an email and they call us back, well, what does that mean about their relationship with us? And trying to be more predictive of what we expect them to do next. If we send them another email or give them a call.
Cool. Nice, looks like we got the.
Which one was it?
Hit the top left icon, we can collapse the side panel.
How's that?
Better.
Perfect.
We go bigger or is that good?
That's good.
Okay.
We can open up line 9. So I kind of run you through like the bread and butter of the system. So kind of walk through, you do your data preparation, you prepare and configure your model, but what we're really wanting to do is that we want to set up our system that trains our data, evaluates our model on those synthetic records, and kind of continually and iteratively improves the model based on those unseen records. So it's a lot of code going on here right now, but essentially what we're doing is, if you scroll up, Chris, please.
Oh, you want to go to get data set?
Yeah, go on this part. So what we do is that we take our test data set, which is just a held out partition of our original training set, and we combine that with some of our augmented test data. We do that because we want to kind of increase the size of the evaluation set that we're looking at, and we do the same for our training set, well, our evaluation set, eval_y. So what this process looks like is after you train your model for the first time, you evaluate your metrics on the augmented and the test data to get your initial metric. And what we're evaluating our models on AUC, that's area under the curve. We like to use that particular metric at CoStrategix because it allows you to combine a lot of the best metrics of precision and recall to really dive a little bit deeper into how's my model performing. Because sometimes your precision accuracy metrics can be a bit biased when you're using those independently. So if we scroll down to the for loop, so what we're doing here is we set up a while, and so we kind of set up a challenger champion structure. And so we wanted to say, based on the previous run's metric, we just want to continually run training iterations until the current run no longer beats the previous run. And so that's a way for us to continually inject synthetic data into our training procedure and evaluate the metrics as we continually iterate through a model. And it's actually like a micro scale of how machine learning operations is set up and how you can like manage your machine learning ecosystem. But we downscaled it to this particular method so that we can monitor the health of our model and have checks and balances for when we should end our training to prevent overfitting. So that's kind of how the code's set up. We can, similar to the slide deck, we can kind of share this code out. There's no proprietary information involved, but if you want to kind of be able to dive deeper into the code and see our implementation, we can definitely share that with you. So what we're going to do next, we're actually going to run the code. And so what the code's going to do, you're going to see the console. It's going to run through print statements of printing out the evaluation metrics for each training run, so that we can actually see how the model is going to be boosting performance after each iteration.
We're going to be running it with 1,000 out of the hundreds of thousands. You ready to run?
Ready to run, yeah. Okay, so these are all the warning signs you get when the TensorFlow is booting up. So as you can see, we're training on 2 epochs to also simplify time. Training on epochs and kind of tuning your hyperparameters is something that's project and task specific. We use Keras tuner library to tune our metrics before we ran the demo. So you might have seen there was actually a dictionary of all of our hyperparameters that we inputted into our model. So it runs really quickly with 1,000 training steps, but you can see down here, this final evals is where we're really tracking our metrics. And so although the model's overfitting because we don't have a lot of training data, you'll see that our first AUC metric is 0.94. And so what it then does is it trains again, injecting some synthetic data. And the second iteration, the AUC score improved to 0.95. And so it wants to be able to see if it can beat it again. So it trains it for a third time, and since it did not beat the previous score, it stops training. It uses that as the best model, it saves that off, and you can now use that to evaluate and use other metrics to kind of dive deeper into model performance and inference. As part of our discussion, when we trained the model on the larger data set, our AUC score originally was 0.3. And then we had about 4 iterations of continual training with synthetic data and ended with an AUC score of 0.95. So what that really means is that it kind of weighs the ratio of precision and recall in your training data set. But it's really still important to have human-in-the-loop components to really validate any particular biases across categories, across types in your data set to really make sure that your model is performing and evaluating and learning on what you expect it to. So if we look at further applications, what we've designed is a framework that's project and application agnostic. So if you have applications where you're not using text data, but you're using audio, images, video, this application still applies. You still need a lot of training data, and you need a lot of it. And so being able to use this synthetic method, obviously how you're developing your synthetic data will be different. So for example, images, there are actually a lot of rich deep learning libraries that will allow you to augment data that are different than the process we use, but the synthetic and boosted approach is definitely generalizable to a lot of your different applications. And because the application allows you to expand your entities, so we work with brands and products, we can expand it to measurements of products, we can expand it to other entities that are important to your business case that allows you to really take off and boost performance. It's really important to measure. Measuring is going to be probably the most critical part. Language models are complicated, and so are their algorithms. So it's important to make sure that although you see strong AUC scores and other metrics on your screen, be skeptical. You need humans, you need experts to really dive in and say, what this model identified is correct. What it's learning on is correct. And so as you continually validate with human experience, you can trust models like what we demonstrated out in the wild and in production that they're actually going to be doing what you want them to do. That's the end of our presentation. We can take any questions. Yes.
So you kind of talked about, you generate synthetic data, but sort of you didn't go into the process of how that went. Was that mostly sort of like a causal, these words get kind of kludged together, these ones get separated, so somewhat informed or expert informed, is that like how language kind of gets mangled?
Sure.
Is that like a procedural process that you just call a function, it goes generate some more synthetic? Or is it learning from their neural nets, learning sort of like a GAN or like a VAE or something like that?
That's a good question. So for us, we didn't use GANs or anything because we were using text data. But to kind of give you a general structure of how LSTMs work, so you have your input, which is a vector representation of your text, because machines can't read, so they read in numbers. And so you vectorize your text as an input, and it goes through various transformations. It goes through input, it goes through forget, input, and output gates. And these different gates kind of allow the model to evaluate and understand what's important in a text. And so when you're constantly learning sequences, we learned that there was a bias in our text data where brands showed up in very similar positions in the text. And so through that, we learned that our model was being biased to the position of a word in a description rather than the word itself, which caused bias on how it was looking at inference. So when we created our synthetic data, what we did is after we processed our descriptions, we then shuffled the order of words in our text. That allowed us to alleviate bias in our data set and improve the model. And so, yes, we created a function, a method that allowed us to read in data, process, shuffle records, spit it back into the model.
And that distribution was kind of well known, like how those state transitions would happen, right? Or they were just kind of
We use
random
distribution of shuffling. Because we wanted to at least see baseline first. Can we remove the brand from the first position? Does that improve the model performance? Yes. Then we can dive deeper into more systematic approaches on how we're distributing tokens in our strings. Of course. Yes.
So the synthetic data, was it refabrication of your training data set, like just take words out from your, like, the text that you're showing and just put them in different order? Or is it could be any word that doesn't exist in the dictionary?
So you can do it a couple different ways. We used our training data set and we did augmentation on that set because we knew that the words and brands and products that existed in that training data set was representative of the catalog of the business, which allowed us to maintain that domain specificity. But you can utilize other methods where you inject similar words or you inject opposite words for different applications. So if you're doing sentiment analysis, you might inject different meanings of words in your text to synthesize it so it has a more generalizable understanding of words and meanings. So we use the training data set as our synthetic baseline. So there's a question.
Yeah, so if there's an unexpected spike or the market is down and your number change, how does that impact your model? So if there's a spike or the market is down, there's something you didn't see before, how does that impact the model and how do you recover from it?
When you say spike, you mean
Like let's say your sales, for example, it goes down unexpectedly, drops by 80%. How does that impact the model?
So our model doesn't, it's not currency, it's not dollar dependent. So how that would potentially impact us would be if you're opening up a new marketplace, allowing vendors to sell products on your store, and you're looking at brands and products that you haven't seen before. And so only training on your original catalog data set can lead to bias and being incorrectly labeling unseen records. And so to alleviate that component, that's where we're doing the shuffling so that it learns an embedding space of what brands and catalogs sound like. But it's an ongoing issue, really. It's a challenging problem to solve. But through synthetic records, through subject matter experts, you can really start to answer a lot of those questions. Yes?
You may have to dumb it down a little bit for me.
Sure.
So you have the area under the curve from sure and half, and it's the measure of accuracy, right? How does the machine know it's accurate? And I work in a world of numbers all the time. I know 12 equals 12 or something like that. How does it know it's hitting the mark, and that you're getting these 93.4, 94, 95? How does it,
Sure.
How does it recognize success?
So what happens is you take a string and you chop it up into a list of words. And what the model does is it looks at this new list of words and it predicts whether it is or is not a brand. And so what it's then doing is basically taking a summation of, I correctly labeled this word a brand and I miscorrectly labeled this word a brand. And so it takes that summation and says, I had this much accuracy, I had this much precision, and it uses those two numbers to then calculate your area under the curve. So it's a word.
How does it know it's accurate? I guess that maybe that's where I'm.
So it looks at, so we have labels. So imagine these list of words, your brand is 1 and everything else is 0. And so when it looks at a new list of words, it predicts each word being 1 or 0. And it basically looks at the label and says, you correctly labeled, let's say 60% of the words in this list, and you miscorrectly labeled 40%. And so it uses that as its way of knowing if it correctly labeled or mislabeled.
So it's not just it labeled something, but it does actually know it accurately labeled it as well?
Yeah, so as a part of the process, you actually have a mapping that kind of lets you know if you're properly labeling or mislabeling a word. And so it does a token level or a word level prediction, and it bases its accuracy off of that word level. Is that helpful?
Better.
Okay.
Thank you.
Sure.
So, just to kind of go back and ask, for the synthetic data, is there a particular ratio of synthetic data that you're injecting into this, or is it like 1-to-1 where we have 1,000 records when we, synthesize 1,000 records? And with that, a lot of the time if you have this kind of small base problem, hey, we only have n equals 1,000, we synthesize that out to n equals 10 million, any biases in that 1,000 are still present across the group. So besides that position shifting we already talked about, are there any other methods you've used to combat that?
Yeah, so we like to try to use the law of large numbers. So as we can continually inject, so if we take the same record and we create more iterations of synthetic data, we can start to normalize the distribution of any biases that might have existed in the original training set. So that's like another way that we try to alleviate that very real problem of if your training data is biased, your synthetic data could be biased, but by iteratively creating a lot of different augmented records, you can start to alleviate some of that bias across your distribution.
And then, you know, the first part of the question of like, how much of this data are you synthesizing for training?
Sure. So for simplicity, we divided our data set into 10 buckets. So there's 10 buckets of synthetic records that we're injecting each iteration of training.
Cool. Thank you.
I think you had a question, Melissa.
Yeah, and I had a follow-up question on how you arrived for like using like the AUC as like your objective metric, because I'm assuming if you have your list of words, most of them are not brand words, right? So is there like, did you work with like your vendor or your client to determine like how to, like was there a cost of miscategorizing a brand, for example, and how you incorporated that? Does that make sense?
We pretty much used a balance cost function for it. There wasn't
Okay.
Anything specific that would have warranted us like saying, hey, okay, we'll put a little more weight here, a little more on the different types of errors. So it was just a balance cost function for that. The one thing too, I mean, with our client was kind of coming at it from like a different angle. They don't have 300 million products and anything, so they were really just trying to take human beings that were doing this and replace them with a model. Not to put them out of a job, but that humans stopped being able to keep up is what it really came down to.
Okay.
So they really needed to augment with a model so that they could process all the items that are getting added to their marketplace.
Okay, makes sense.
Just another quick question. So is the pain point from the customer is they don't have a clear product hierarchy, or new products are coming in every day, they don't have a clear kind of adding those SKUs into the product?
They don't have control over the data. The data's third-party data, so it's basically garbage. And so that's why they have manual annotators in the first place. It's because they don't have control over the ecosystem of all these new marketplace entrants coming in. So if it's like, you know, a large manufacturer or something like that, they have clean definitions of the brand name, their product, the images associated with it, all that are going to go in the marketplace. But for a data quality standpoint, they have to have these manual annotators. Not so much anymore, but up until this point. You know.
There are two questions here. I don't know which one. Can I take her question? She hasn't asked one yet.
Yeah. So actually, I have two questions. First is more logistic.
Sure.
What was the amount of training time? What resources were you guys using on this size of data? Were you using EC2 instances? Was this 10 hours, 24 hours of training? Or sure, are you able to share it with that?
You can share it on your laptop.
I mean, I ran about 100,000 for this. I mean, for this discussion, you know, it ran fine on a i7 with, you know, about 16 gigs of RAM or whatever, and no problem, maybe about 3-4 minutes. But we were using Azure Cloud Services for the client application, and then we actually also then, after we proved out everything, then it went to their environment, and so we set them up for deployment, but we're not part of that deployment and don't get a lot of the metrics that we even create the MLOps for them and have the metrics and stuff. But we don't so much get to see them unless there's a problem. Yeah. But what was it, like eight cores, two machines, just kind of, it wasn't that, it didn't require that much BP of a box, and then I think it runs for like 10 minutes. They don't have massive Amazon or Uber or that kind of scale data. So it's pretty reasonable, and it wasn't very expensive because I was tracking some of the cross when we were running it in our own environment, so it wasn't like going to break the bank or anything like that. The larger problem was really just fixing this inbound bottleneck of getting items out into their marketplace. So,
yeah. Just a quick follow-up question. It's actually a bit related, but you guys mentioned you're using LSTM. Have you explored or considered an alternative, just like a basic RNN or transformers of the rage these days? You guys looking at those options?
yeah, we did. The paper actually, the paper for Home Depot actually used a GRU. We got real good results on the other one, and I think it had a lot to do with their brand positioning was the way it was. A lot of them really were in that first position in terms of the words, so the BiLSTM was working pretty well. I mean, we played around with the different middle layer of, we had conditional random fields in there. There was another one where they actually just used another LSTM character layer, so we were not just breaking up the words, they were breaking up the character, but this was kind of a good trade-off between cost, speed, and, you know, performance. And we also, one thing, this gentleman asked earlier about how you know who's right. We also do build an audit into our process, so we take random samples once a week or multiple times a week where a human will then look at just 100 records and say, did the model get it right? And those small number of records can actually have a huge impact in moving the accuracy of the model. And that helps especially with, like we were talking about, when new brands get introduced, which happens all the time. So,
Any questions?
Often, the natural language processing problems come down to building a library and how accurate is your library. Like you just talked about when new brands get introduced. So, is there an underlying library? That's my first question, and then a follow-up to that is that, sometimes brands have sub-brands and sub-brands have, so, is there a hierarchy in that library? So that's my two questions.
I would say that that hierarchy is established at the organization level. A lot of your data comes from that catalog information. So a way that we have experimented getting around hierarchies and kind of understanding like sub-brands is by having a stronger embedding layer. Can we take like language models like BERT and Elmo to really increase the recognition of words that exist out in the world and use that as our way to recognize new information that we haven't seen and start to lean on their embedding space to create a hierarchy for our data set.
There is a library, for your brands, a dictionary.
There's a catalog that shows you, that has a list of brands and the products that exist underneath. So we use that as like our base benchmark, a library or a hierarchy that we then apply to our problem.
but that's not necessarily going to capture every possibility in the marketplace, because that's usually that product catalog is based on what you sell in your physical stores if you have a physical presence, or like if you're Amazon, you've got 12 million private label products that just have your own name on them. So you lean on that, but it's not going to give you every possible iteration. Another thing you can do is if you do have if the individual does have or the company has a search, like I'm searching for this product on your thing, you can use those searches in different iterations and orders of those searches in the sense of, hey, here's ones that are just a brand. It's just, I'm searching a brand on bestbuy.com, I'm searching Samsung or something like that. And then it gets a little bigger, it's like Samsung refrigerator. And you can use those searches, and that's another noisy data set. It'll be noisy, but you can use that to get a little bit of lift in your model as well, if you have inbound search traffic. And a lot of the bigger companies do that. Yeah.
So in terms of this explainability of these models, particularly like LSTM and all this stuff, so do you have any kind of challenges explaining to the business audience? Because usually the practice is taking this kind of neural network or decision tree models and using standard models to show the explainability of these models. So did you have to do any of those kind of things to your client?
We did. So our first iteration, we had the challenge of the initial bias of only predicting brands in the beginning of a string. And so through that, the model was actually picking up non-brand words. So that was like our initial hurdle that we had to do. So in order for us to increase our explainability with our client, rather than having a generalized metric for model performance, we then localized it to token level. So we used metrics like partial match, and that was a way for us to kind of say the model has this general performance, but now at a word level, here's the accuracy or precision on its partial matches. Did it get the brand and something else? That's a partial match. Did it miss the brand completely and grab something different? So we drilled down a little bit deeper in our metrics at a token level to explain how our model was performing at a word level. And so that's been able to help us like gain that trust with the client to say there are a lot of human in the loop and evaluation steps we need to put in place, but you can now see that the model is actually improving because it's grabbing the brands more often. It's grabbing non-brands less often so that we can actually start to trust it and improve on it. I think you had a question, Lynn.
Do you ever face data deduplication errors? For example, a brand can be present with its full expansion. It can also have a short form of it. So how did you tackle that? If you ever faced it? Did you have to use any fuzzy matching algorithm or sort of the other fuzzy matching algorithm that we use for data retrieval before LST? Or how did you tackle that situation?
We did that in a prior project with the same customer, and they were probably about the one that I kind of jokingly said, like there were so many algorithms in there, we lost track of all those methods that we did. And again, it was a similar problem. It was a string of text, and we were trying to identify an entity in it, like a particular type of food. And we found that again, those models can do the job, but they don't do real good on that out of sample. And in this, so in this marketplace example, like we're talking about, they're going to introduce new brands, and so I'm constantly going to be having to update those algorithms with those new brand names coming in or those new products coming in. Yep.
You got a question?
Yeah, can you talk about that process of adding new brands? Are you augmenting the model with human-coded data, or is there new searches you have coming in that you can augment it with? And also kind of related to that, if you were to have like a rebranding or an acquisition, how do you deal with those multiple entities pointing to one catalog?
So we don't manage their catalog. We just manage this manual brand verification process that's outside their catalog, but then information does, once it gets to a certain level, it does get sent into the catalog. But let's see, with the cases you had, you were an acquisition, new brand coming in, and what was the other one?
Rebranding.
Yeah, rebranding. So it's again, those are what those audits will do. So those might get, let's say those get introduced in the data set. We have, MLOps set up such that it will retrain a model anytime something it doesn't see happens, and then we also then send those audits out every time. So it may take a hiccup week in, week out, like, the model performance might go down a little bit, but we see that it usually creeps right back up. Like we haven't had like a dramatic drop off in performance. It's actually been pretty steady and steadily increasing. Obviously it's not gonna go much higher than a certain percentage, it's just gonna be overfitting, but yeah.
Thank you.
So whenever you receive a catalog from a customer, do you have a metric to measure how good the catalog was?
You mean in terms of like the quality of the contents
quality
of when they send us a list of new products?
Yeah, I mean, let's say if I have two customers,
Mhm.
so you say customer 1 data is slightly better than customer 2 data. In terms of the amount of information you're able to extract based on your algorithms.
There is a longer term vision now we've done probably 6 projects with this company. There is a longer term vision that is going to have that sort of quality score for inbound data, but we're not there yet. It's a journey that we're on with this customer, and so, but yes, it's definitely been considered, but we need more data to compare between different vendors, because they don't have a lot of contact, like they do not, like I said earlier, they don't have a lot of control over these marketplace folks or their the manufacturers that they work with either, so it'll take us a little while to get to that level of sophistication. I know it sounds kind of like a simple thing, but getting multiple files from multiple entities to do that kind of crazy, it hasn't built up that data yet.
John, how long did it take you to complete this project for the customer?
This was over a few months.
Yeah, this one we got good performance early on, so it was probably
So the
2 months, and then that doesn't include deployment and integration into their system and everything like that, but actually the modeling process was about 2 months.
Yeah, to build the model, get the data right, and kind of do some initial validation, a few months, and then from there it's
So when you're doing the translation of your problem from, like earlier when you were saying from words to numeric, how are you translating context to explain Apple the fruit versus Apple the brand?
That comes through our model architecture and our embedding layer. So when we feed our sentences into our network, our embedding layer is what creates that. It translates our input into an embedding vector based on, we use BERT for our embedding layer, but we lean on those features to add contextual context.
Another thing we've done too is actually, broken things up by category and trained within a category, like the example you gave, like fruit and vegetables. Those are some of the hardest categories actually, because there's flavors, there's real words that mean the same thing as the brand name. Like that's actually those fruits and vegetable ones and other ones that don't have, like Goldfish is a clear brand, like Kellogg's is a clear brand, Coke is a clear brand. Those are the ones that we had to do a little bit of extra training. And one way to do that is either stratified sampling or just, modeling within a subgroup of a category.
One of the biggest, so our team was actually working on sentiment analysis of consumers, and one of the biggest challenges that we faced was in sarcasm. It's very, very hard to tell, but I guess that's not such a big problem for you guys.
Yeah, I mean, they're getting better even with things like sarcasm and things like that in terms of like these big, huge, millions, hundreds of million record embeddings like Glove and Elmo and some of the ones we mentioned today are helping with that. But yeah, that's a tough one, right? Or Apple the fruit or Apple the product, like those are always going to be difficult. But it starts looking for the things that are around them. Like for example, Apple, a lot of these are for not only do they do it for search, but they also do it for like price comparison. And they're really good at finding like that's Apple and not Apple the fruit when they're trying to compare the price of laptops across multiple retailers is a domain where they've gotten really pretty good at that.
Specifically to sentiment analysis, I've used libraries where I've either replaced words with synonyms or I've dropped words in the text to kind of add to that augmented data set, so I can try to, even within the contextual sentiment analysis, you can still get really good results through doing some augmentation that way.
You talked about this concept of model ops and like the the concept of like automatically retuning and retraining your models. Can you speak on the tech stack that you used to implement some of those things?
We used, like I said, we used Microsoft Azure, and they have their own commercial implementations of open source packages like MLflow, DVC, the data version registry, model versioning. They have all that stuff with their skin on it. But yeah, that's pretty much right. And you'll find that with all the big cloud providers, and then or you can just go right to the open source packages.
Okay.
Any other questions?
So you mentioned that the model is hosted at the client's premises.
It was more of a handoff once
Okay.
at the end of the project, and we include documentation and all those things to them for them to operate the model themselves once we've done all the development.
Was that contractually, or is that something you see consistent as opposed to exposing your models and continuously improving it on your end and then expose it through an API?
The legal way that our contracts are worded, they get the IP, so that's going to be up to them.